Hi math friends, we're going to check out our study guide here for our statistical questions. And our first part is analyzing if these are statistical or not. So remember, statistical, we want to get a variety of answers to have a lot of variance to our data. So we're going to look at these carefully. What is your favorite animal? So it's only asking what is your favorite animal. We're really only going to get one answer there, so it is not a statistical question. And we have some options here to try to change it to be a statistical question. So we could say, try to change this light here. It is statistical. No, it's not. What is my favorite animal? So only asking one person, not going to work. What is the teacher's? Nope. What is the favorite animal of all of the sixth graders? So that's my clue. That provides a lot of variance to my answers. All right, let's check out this next one. What video game console does Alan like the best? Again, not statistical. So which of these would be statistical? Does Mr. B like the best? Does the class like the best? Or which is coming out next? So when I say the class, that means that we're asking a lot of different people and getting some variance there. Classify as statistical or not. How many students per grade level are in the band? Well, per grade level, yeah, there's different grade levels, so I will get some variance to my answers. So we'll say it is a statistical question, choice A. Kind of circled A and B on accident. Yep. Number 4, Ricky studied data from the following categories. We want to select the quantitative data. So when you get numbers, types of Oreo cookies, so I'd get like chocolate and peanut butter and all the holiday flavors they do. So that would be types, that wouldn't be numbers. Number of animals in the zoo, yep. Amount of books, yep. Types of push-ups and first names. So I would get things, but I wouldn't get numbers there. Categorical, so the opposite, I would get types of Oreos, types of push-ups, and first names. Let's check out this dot plot. It shows the number of hours students sleep each night. The number line represents the number of hours. Each dot above the number line represents a student who has that amount of sleep. So one student for 6 hours, one for 6.5, one for 7, and so on. What do the 2 dots above the 8 represent? So remember, these are students. This is 2 students. I got 2 students, 2 students, 8 students. No, that's just wrong. And then this is my time for sleep. So they had 8 hours of sleep. 8 pillows. That's not right. So A is the correct answer. Why is there no number 11? So if there's no data here, it's because there was no data. No students reported 11 hours of sleep. Identify the outlier here. So outlier would be something really far away from our data. So maybe these are kind of far, but they stay with our trend here. Remember, we can think of there being like a curve to our data here. All right, so there is no outlier. All right, let's check out these graphs. Which graph shows a skewed left distribution? So remember, we can set a curve on each of our graphs. Think of it like that. And this one is about the same on both sides. This one is symmetric. Now skewed left and skewed right. So there's a peak here, a peak here. This one goes this way. This one goes this way. So slopes to the right, this is skewed right. Slopes to the left, this is skewed left. So graph 2. All right, let's check out this dot plot. It shows the number of brothers and sisters a number of students have. Each dot above the number line represents each student that responded. What is the distribution? Curve over here. This one is perfectly symmetrical. So it doesn't have to always be perfectly symmetrical, but it has to be close. This one is symmetric. Explain the distribution of it. So we want to think of, we have most students are at 2 siblings, and then we have a little variation going each way to 3 and 1, and then to 0 and 4. Okay, so let's write something like that. Most students have 2 siblings. Then there is symmetric variation going up to 4 and down to 0. Right? So remember, these are going to be the exact same when you write your explanation, but it should be explaining the data that's here. A statistician for a chain of department stores created the following stem and leaf plot showing the number of pairs of glasses at each of the stores. So this is for a number of glasses. So we're not given a key, but we need to think about what key would be appropriate. So would I sell 9 pairs of glasses or 0.9? I would probably sell 9. So I'm going to go through this. 1.3 pairs doesn't make sense. This one's just wrong. 1, 3, 18. That's not even the right digits. Now I've got 3, 0 meaning 30 or meaning 3.0. Well, let's look at some other options. 4, 1 would be 4.1 or 41. It'd be 41. 4, 2 would be 4.2. No, it would be 42 for pairs of glasses. We want a whole pair of glasses here. So I would have C being the correct thing. All right. Our next question asks us about that again, so we'll have to refer back to this. So let's go ahead and check. What observations can you make from the information in the stem and leaf plot? Select all true statements. The most frequent amount of pairs of glasses is 47. The most frequent amount of pairs of glasses is 16 and 43. Okay. So most frequent, we're looking at the mode. Remember, in the same stem, so I've got 2 6s here. I'm looking for any numbers that repeat in the stem. Got 2 3s. So we have 2 modes. 1 6 is 16. 4 3 is 43. All right. Remember, don't be confused that there's a 6 over here as well, because this is 26 right here, not another 16. So these are our 2 modes. So 16 and 43. Not part A. The data is approximately symmetrical. The data is right skewed. Well, let's check it out. So if I look at my data here, if I think of my curve, so kind of putting it sideways like this, I don't really see that it's either one of those. If I had a few more in the 30s instead of the 40s, it would be approximately symmetrical, but not really. So I don't have the right kind of thing here now. The range is from 9 to 47. The range is from 0 to 47. Let's see the range. Range would be highest minus lowest. 4, 7. So 47, 0, 9 would be 9. So that's our range. Subtract that. So our range is 47 to 9, which is 38. So E. So our only answer choices here are B and E. Now let's check out the shoe sizes of students here. We have a histogram. It says describe the data represented here. What does the title tell you about the data? So look at your title, right? It tells us that we are looking at shoe sizes of students. We are looking at data for student shoe sizes. What does label on the horizontal axis? Oh, wait, that's a good word, horizontal. Remember, horizontal is sideways. So this axis, shoe size. So this tells us the shoe sizes that were recorded. Right, we didn't have anything below 6. We didn't have anything above 12, really above 11 and a half, because this is a histogram. This one's a little bit tricky. Are the data represented in the histograms bars discrete or continuous? So discrete, you cannot have a fraction of a student. Well, that's true. We cannot have a fraction of a student. Discrete, you cannot have shoe sizes such as 9.5 or 8.5. Yes, we can. We do have shoe sizes like that. Continuous, you can have a fraction of a student. Not true. Continuous, you can have shoe sizes. Yes, we can. All right, so which one is it? It's either discrete or continuous. So when we look at our data here, our frequency, this is the number of students that responded to these questions. So I cannot have a fraction of a student here to respond. So it's actually discrete because of that reason. All right, let's check out number 10. What is meant by formulating a statistical question, the first component of the statistical process? Okay, so this is where we are trying to answer a question about the world by asking multiple people for their opinions and analyzing data. Okay, so sometimes it's opinion, sometimes like shoe size, not really an opinion, but it's what do you have? So we're asking them for data. Give an example of a question that is statistical and a question that is not statistical. All right, so I'm going to keep this simple. Is statistical, what is the favorite ice cream flavor of 6th graders? So I would be asking all of the 6th graders and getting a lot of different data. Not statistical, what is your favorite ice cream? So I would only be asking this to one person. All right, so work at this, right? You got the study guide, and you have been working hard. You got this. You're going to be all right.